Here's going to be the Unit 6A review, okay? So question number 1 says, Part A says, write an equation that describe a line that passes through the point -6, 9 and is parallel to the line described by y equals 3x minus 5. Okay, so what it's telling us here is we are going to write an equation. Okay, it's going to go through this point, which I know is x1, y1, and it is parallel, okay, that's a key word there, parallel to the line described by y equals 3x minus 5. Okay, so it's asking me to write an equation. So when I talk about parallel, I know that parallel means same slope. Okay, so if I go ahead and look at this here, I know it's set up in y equals mx plus b format. All right, I can kind of compare those. So I know that my m, which is slope, is always what's in front of x. So my slope given here is going to be 3. So I have m equals 3. All right. So since I have the same slope, I'm going to use this m equals 3 that the equation gives me. Okay. So I'm given a point and I'm given a slope. So because of the information given, I go and check my formula chart for linear functions. When I'm given a point and a slope, I'm going to use point-slope form, which is y minus y1 equals m, and then in parentheses x minus x1. All right, so that's going to be the equation that I use here. So I'm going to write this right here. I have y minus y1 equals m, and then x minus x1. All right. So I'm using my point-slope equation because I'm given a point and a slope. Now I've got to plug in the information that I have. All right, the pieces I have to plug in is y1, m, and x1. So I'm going to go and do that at this time. So I have y minus y1, which we said was 9, equals m, which we said was 3. And then in parentheses, I have x minus x1, which we said was a -6. All right, so now I've got to go ahead and get this and back into slope-intercept form here. So I have a negative times a negative. Whenever I have a negative times a negative, that is going to give me a positive. So I connect those and I make that a big old positive. Now I've got to distribute this 3. Okay, I've got those parentheses there, so I have to distribute, and I draw my little multiplication symbol. So I still have y minus 9 equals, I have 3 times x, which gives me 3x, and then I have 3 times 6, which gives me a positive 18 there, okay? So now my next step is going to be to get y all by itself. Right now I have a minus 9 attached. So in order to get rid of that minus 9, I have to add 9 to each side. Okay, that cancels out because I have a minus 9 and a plus 9. So now I have y equals, I have this 3x, and then I have a positive 18 plus 9, which is going to give me 27. Okay, we're going to go ahead and check, though, to make sure that these are parallel lines, and it goes to the point -6, 9. All right, so here we go. I have the line y equals, I have 3x minus 5. That's the line given to me. Now I'm going to plug in my point. So the point is -6, 9, and I'm using Desmos to check. I can go ahead and label that point. All right, so I zoom out so I can see that a little bit better. There's my point. Now I'm going to check our equation that we just wrote. Remember, it's got to go through that point, and it also has to be parallel to this red line we've already added in here. So my new line is y equals, I have 3x plus 27. Okay, so now I can look at what I have here in Desmos. I see that these are parallel lines. They have the same slope, which means they will never intersect. Okay, they will run side by side forever and ever. And if I look, the function that I wrote, which is my green function here, okay, it goes through my point. So now I have successfully written the equation of a line that goes through the point negative 6, 9 and is parallel to the original equation given. So this is my correct answer. I put a box around it, and now we are moving on to part B. All right. So now let's go ahead and look at part B. Part B says, write an equation, so that's once again what I'm doing, write an equation that describes a line that passes through the point negative 6, 9, which is once again x1, y1, and is perpendicular, which means negative reciprocal, okay, to the line described by y equals 3x minus 5. All right. So now I've got to write the equation of the line that passes through this point and is perpendicular to this line given here. Okay. So when I have perpendicular, I know that I have to take the negative reciprocal. So I first got to start with the slope that I have. So it gives me m equals 3. Okay. It's the same equation I had up here. So given m equals 3, I now have to find the negative reciprocal. So in order to find the negative reciprocal here, okay, I have to take this 3, which is a positive 3, and if I'm taking the negative of that, I have a positive times a negative, it now becomes a negative. Okay, I'm given a positive, so now it becomes a negative. All right, change my sign. So if it was a negative, it would change to a positive. But here we have a positive, so it changes to a negative. All right, it says reciprocal. Okay, reciprocal. Right now I have 3 over 1. Okay, I have 3 over 1 because I know that underneath this 3 here, there's that imaginary 1. Okay, so right now I have 3 over 1. Reciprocal tells me I'm going to flip that. All right, so I now have 1 over 3. So now I have 1 over 3. So I've now found the negative reciprocal of my original slope of 3. I changed my sign, okay, I went from positive to negative, and I flipped my fraction there. So I originally had 3 over 1, now I have 1 over 3. So now I've got to use this slope in order to find the perpendicular line, okay? So once again, I have a point and I have a slope, so I'm going to use point-slope form. So I have y minus y1 equals m, and then x minus x1. All right, the pieces that I have to change are y1, m, and x1. So I've got to plug in that information now. So I have y minus, I have y1, which is 9, equals my new slope. Remember, we're using our new slope, which is negative 1/3. Then I have x minus that negative 6 there. Okay, so now same thing I did on the previous problem. Now I've plugged in the information I have, but now I'm using my perpendicular slope. All right. So now from there, I have a negative times a negative, which changes to a positive, and I've got to distribute this negative 1/3. When I distribute, remember that is multiplication there. Okay. So I end up with y minus 9 equals, I have negative 1/3 times x, which just gives me negative 1/3 x. Now I have negative 1/3 times a positive 6 there, okay? Negative 1/3 times a positive 6 there. So I have negative 1/3 times 6, which gives me that negative, oops, sorry, I didn't have that on the screen, I'm sorry. So I have that negative 1/3 times 6. And remember, you can hit alpha y equals to get a fraction form that looks prettier than this, okay? So remember, you can hit alpha y equals to get a prettier form of that fraction. All right, here we go. So I have minus 2. Now I've got to finish this. I've got to get y equals all by itself. So I've got to move over this minus 9. In order to move over that minus 9, I have to add 9 on each side. Those cancel out. I get y equals, I have negative 1/3 x, and I have a negative 2 plus 9, which will give me a positive 7. Now we've got to use Desmos. Once again, we're just going to double check our work. All right, we're going to use our resources, so we're going to double check our work. So I'm still working with the equation 3x minus 5. So I can leave that first line there, that first equation. My point is still negative 6, 9, so I can leave this second equation. All right, third, I'm now going to change this equation here. So I'm going to exit that one out. So I get y equals, I have negative 1/3. Okay, I have x plus 7. So now if I look at my graph, I have perpendicular. Okay, remember that's when they cross perfectly. I could draw a little 90-degree angle there. Okay, and I would have I'd be able to see that perpendicular intersection there. All right, so if I look, my perpendicular line, which is now the purple, goes through my point. So I can now see that not only is it perpendicular, but it also goes through the point, negative 6, 9, which tells me my answer here is correct. Okay, go ahead and exit out on all this. All right, so now let's go ahead and talk about 2a. 2a says, write the equation of a line that is parallel to the x-axis and passes through the point 4, 6. Okay, so it's talking about the x-axis here. All right, so whenever I'm using this, I've always got to do the opposite. So I know that the x-axis is going to be y equals 0, and I'll show you what I mean by that. Okay, if I plug this into my calculator here, I get y equals 0. I can see, and I'm going to change that color for you real quick if it's going to let me. All right, there we go. That orange line now represents my x-axis. That's the way it goes. It's that horizontal line there. So I know that I'm talking about y equals 0. All right, that's what it showed me here. So it says that is parallel and passes through the point 4, 6. So now I can go ahead and add my point of 4, 6. I'm going to go ahead and label that point. So now I see that my point is up there a little bit of a ways, okay? So I've got to write the line that will go through that point. So I know we're talking about y equals. So if I look, my y value at this point is the 6. Okay, I can label that on here too. All right, my y value, because this is my x value, that's my y value. My y value is the 6. All right, if I was to draw the line right here, I would intersect that point. That is at y equals 6. All right, so I'm going to go ahead and plug that in just to make sure we have the right answer. So I have y equals 6, and I'm able to see that not only is this line parallel, okay, they're going to go on forever and ever and not touch, but it also goes through that point. All right, so my answer here is going to be y equals 6, which is that blue line. So y was 6 here, so my answer is going to be y equals 6. All right, now let's go and look at the next one. It says, write the equation of a line that is parallel to the y-axis now. All right, so now I know that it's y. I'm going to talk about the opposite, which is x equals 0. Okay, I'm going to go back into Desmos, and I'm going to go ahead and check this equation here. So I have x equals 0. Okay, that is my, that is my y-axis there. All right, I can see that is my y right there. Okay, so, and it says it passes through the point 4, 6. So once again, I know that is x, y, and I'm going to go ahead and plug in that point. All right, I go ahead and hit label. I can now see that point there. So now it's talking about our x values. So if I look right here, I go over 1, 2, 3, 4. My x value, where I could get this vertical line, is going to be at x equals 4. All right, once again, my x value right here, because we're now talking about x, is 4. So I'm going to go ahead and try the line of x equals 4. X equals 4. Okay. Let's go ahead and go red. So now I'm able to see that these lines are parallel to one another and it goes through the point 4, 6. All right. So now I've written my parallel and parallel lines of the x-axis and y-axis that go through the point 4, 6. Okay. Just as something to quickly talk about before I'm moving on to the back, we do have. This is just our little reminder. We do have Hoy, Vux. Okay. I have Hoy and Vux. All right. Hoy stands for horizontal. I have a 0 slope. And this is also talking about y equals some number. Okay. I have Vux, all right, which stands for vertical. All right. It tells me that it's a u, which is undefined slope. Undefined slope. And it also tells me that it is x. So it is x equals some number. All right, so remember, when I have horizontal, I'm talking about my y values. All right, if I look up here, okay, I have a horizontal line, which is our x-axis. I'm now talking about y values. This is Hoy. This problem right here is Hoy. All right, if I'm talking about this right here, I have x equals 0. My x value, this is going to be a vertical line. My y-axis here is a vertical line. So this is going to be Vux. Okay, please notice how I'm writing it. Hoy is horizontal. Vux is up and down. All right. So Hoy, horizontal, 0 slope, and y equals. All right. I have my x-axis, which is horizontal, but it's actually y equals. All right. Vux, vertical, undefined, x equals a number. I have my y-axis, which is a vertical line, and it's actually going to be x equals 0 there. All right, so Hoy and Vux. Please use those to help you out on the test. All right, here we go. On to the next page. All right. So for this next page, it asks us to graph x is less than or equal to 4. So I've got to find where x equals 4. I go over 1, 2, 3, 4. This is where x equals 4. All right, so now from there, all right, I have to draw my line of x equals 4. I know that it's x equals, which tells me that this is Vux. All right, it tells me that it is a vertical line. We just talked about this on the front. There is that, there is that. All right, so there's my vertical line. So now from there, I've got to do my inequality. So it says less than or equal to. All right, so I did a what am I trying to say? Solid line, because it has this bar underneath there, which tells me that it is equal to. So I have a solid line here. All right. Then from there, I can pick a point that is less than x. I'm going to say 0. Okay. 0 is less than x. So wherever my 0 is, that's the side that I am going to shade. All right. So all of this is going to be shaded there. All right. That is my inequality. I can go ahead and check that in Desmos. Let's see. Here we go. So I have x is less than or equal to, all right, 4. And I can see in Desmos that this now matches, all right, my graph that I have right here. All right, I'm using Desmos as a resource to check my work. All right, here's the last thing it asks. It says, what is the slope of the above line? So I know I have a vertical line. So I know I'm working with Vux here. Okay, this U tells me that my slope is undefined. Okay, so my slope here is going to be undefined. All right, because I have a vertical line there. It is undefined. All right, so now onto this next part, I've got to graph the next piece here. Okay, so using Desmos, all right, I can plug that equation in. I get 2x, x plus y is greater than 5. Okay. Y is greater than, all right. So now, okay, I can see what I'm working with, all right? I'm going to go ahead and solve this so that I can write my slope and my y-intercept. I could also find that from here, but I'm going to go ahead and show how to work it out first. So I have 2x plus y less than or equal to 5. I've got to get y by itself, so I've got to subtract this 2x away from y. So I end up with y is greater than negative 2x plus 5. So now I can go ahead and check that in Desmos just to make sure I did it correctly. So I have y is greater than negative 2x plus 5. So I can now see that it is the same exact, all right? If I'm looking at my original line and I draw my second line there, I can now see that it's double shaded because that represents the same exact line. But I double checked that using Desmos, okay? So now, if I'm looking at this right here, okay, I now am going to break this down. I know this is in the format of y equals mx plus b. So my slope here is going to be a negative 2. My b here, which is my y-intercept, is going to be positive 5. All right? So if I go ahead and graph this using the information I have a positive 5 for my starting point. 1, 2, 3, 4, and 5. There's my starting point. Then this tells me that I have negative 2 over 1. That tells me that I'm going to go down, because it's negative, down 2 and right 1. So I go down 1, 2, right 1. I go down 1, 2, right 1. Down 1, 2, right 1. And so on, okay? But before I draw my line, I've got to make sure I know what kind of line to draw. So if I look at my inequality symbol right here, I do not have the line underneath that inequality symbol, which means it is not equal to. Okay, it is not equal to. I do not have that piece there in order to say that it is a solid line. I do not have that little bar underneath, so I cannot say that it's a solid line. All right, so it is not included. So now I'm going to draw my line, my dashed line here. There is my dashed line. All right, so now I know I'm talking about a point that is greater than right here. So if I was to talk, so I'm starting with 5 right now. If I was to talk about, let's say, 8, this point right here, that is going to be greater than the original number given, all right, which we're talking about a greater than symbol here. So I would shade the above part. Okay, and I can always check with Desmos to make sure that I'm doing this properly, okay? They also shaded the above part, so I can see that our two graphs look similar there, all right? So that would be graphing this equation given, writing down the slope and the y-intercept, okay? If I was to use Desmos to find the slope and y-intercept, I could zoom in a little, okay? I see my y-intercept. It goes through my y-axis here at the point 5. So that's where I get my y-intercept of 5 from. Then if I look, okay, and I was to draw a little bitty triangle here, I would have a little triangle right here. It goes through perfectly right here, and it also goes through perfectly right here. So I have my little triangle right here. So if I start right here, I go down 1, 2 to the right 1, down 1, 2 to the right 1. I have down 2, right 1. So I can see that my slope over here matches what it has right here. So, but I could have figured that out using Desmos and my graph on Desmos. All right, so a couple different options there of how to solve that or figure that one out. All right, number 9 is my favorite problem because I personally believe it is the easiest. If you disagree, that is okay. You will not hurt my feelings. All right, and I am going to go ahead and add on here that this is a dashed line. Sorry, dashed line. There we go. All right, here we go. Down at the bottom, number 9a, it says, is 0, 0 a solution in the inequality? So the point 0, 0 is going to be right here. All right, for A, I'm going to use my purple. So the point 0, 0, it is a part of the shaded region. So yes, it is a solution. Okay, anything within the shaded region will be a solution. All right, so yes, because it is part of the shaded region. Okay, I'm going to give you a couple of other examples that are part of this shaded region. So if I talk about this point right here, I have 1, 2, 3, comma 1. Okay, this point would also, yes, be a solution because it is in the shaded part. Okay, if I talked about this point right here, all right, I have I have positive 4, negative 4. 4, negative 4. All right, yes, once again, this is a solution. It is part of the shaded region. All right, if I talk about, let's go this point right here. All right, I have negative 2, negative 1. Okay, once again, it is part of the shaded region. So yes, it is a solution. All right, so anything in this shaded region will be a solution. All right, now let's go ahead and answer part B. It says, and I'm going to go and do this in pink, is 0, 1 a solution in the inequality? Justify your reasoning. So I have 0 and 1, which is this point right here. Okay? So if I look here, I have a dashed line. So what that tells me is my inequality is not equal to. So anything along this line does not exist. All right, Mr. Bunn explained it as this point would fall through that dashed line. So it is not included. It does not exist. All right, it would fall through that dashed line. So no, this solution does not exist because it's not a point that exists here if it's on that dashed line. Okay, so no, because it is a dashed line, which means the point is not included. Because it's on the dashed line, all right, which means the point is not included. Okay, it is on a dashed line, which means the point is not included. Okay, so now let's go and talk about some other points that are also not a solution. All right, so if I talk about this point right here, okay, I have the point 1, 2, 3, so negative 3, negative 1. Negative 3, negative 1. Okay, so once again, I'm on that dashed line. So no, that would not be a solution there. Okay, if I talk about this point right here, I have negative 2, positive 3. Okay, this point right here is not a part of my shaded region. Okay, it is not in this shaded region at all. So no, it would not be a solution. Okay, just like this point up here. Okay, if I'm talking about the point 0, 4. Okay, once again, this is not a part of this shaded region. So no, it is not a solution. Okay. All right. So what I can do in a calculator, if I have, or in Desmos, sorry, if I have the equation, okay, which if I look at this, I could write the equation of it. I have my y-intercept, which is at a positive 1. Okay. And I have my slope, if I look at my little triangle here. Okay, I go up 2, and then to the right 3. Okay, so my slope would be 2/3 x, and this is going to be y less than or equal to. Okay, so let's go ahead and look at and show you in Desmos how you could check your work here. Y less than 2/3 x plus 1. Okay, so there is the same graph that I have on my sheet of paper here. So now I could go check these points, all right? I could plug in the point 0, 0. All right, I can see that that is a part of the solution. All right, it is within my shaded zone. Okay, I could look at the point 0, 1. Okay, I can see that that's on that dashed line, so it's not included. All right, I could try the point 0, 3. All right, I see that that is not a part of my shaded region, therefore it is not a solution. Okay, so you can check in Desmos and you can see where that point is. All right, so use Desmos as a resource on this test. All right, so that is everything for this test. Couple of things to remember: parallel is same slope, perpendicular is negative reciprocal slope. Okay, if you are talking about a vertical line, that is going to be VUX. Okay, if you're talking about a vertical line, it is VUX, which means that it has an undefined slope, and the equation is going to be x equals something. On the other hand, if you are talking about a horizontal line, that is going to be HOI, so that you're going to have a 0 slope, and your equation is going to be y equals something. All right. Last little review. If it has the equal sign underneath, it is a solid line. If it does not have the equal sign underneath, it is a dashed line. All right. And the final piece, okay? In the shaded region or along a solid line, okay, this is not a solid line, but along a solid line is a solution. If it is not in the shaded region or it is on a dashed line, it is not a solution. Okay, that should be everything for test 6A. Best of luck.